So this is meant to be a video walking you through first some basic factoring problems, just to take them slowly and think about the way that factoring works, thinking through the steps, and then building into some of the more complex types of factoring problems that you have in your Chapter R homework. So I wanted to start with something basic. I've got 3x to the fifth minus x squared. So the common factor here is x squared. We know that because the exponent is the lowest exponent. We always factor out the lowest exponent. So in this case, that's x squared. Now what's left would be 3x cubed minus 1. Now the reason that you get that 3x cubed minus 1, that might be a part of the process where you can kind of complete this step here without thinking very carefully about the details of what you're doing. But I want to talk through the details because it'll help with the more complicated problems. So we had 3x to the fifth, and you factored out x squared. So that factor of x squared cancels, and when you subtract 2, that leaves a power of 3 here. So that's why you have 3x cubed. And then with the 1 that's here, it's because we had x squared in this position, but we factored out x squared. So you can always divide to figure out what your remaining factor is. So that's where we get the 1 there. Okay, so maybe trying to apply that to a slightly more complicated problem. So what if you have negative exponents? Say you have 2x to the negative 3 plus x to the negative 5. So now with negative exponents, it becomes a little more difficult to figure out what the common factor is that you should factor out. Now remember, it's always the lower exponent. It's always the lowest exponent that you should factor out. So you're looking for the lower value out of negative 3 and negative 5. So the lower value is that negative 5. We should factor out x to the negative 5. Now to figure out what's left, writing it as division may not be the best way for me to explain this part. So another way of thinking of the way that we figure out this remaining factor is you should subtract, and this is important enough that I'll put in writing, subtract the power that was factored out, from the original exponent to figure out what the remaining power is. So in this case, from where I am here, I need a pointer. Let's see. So you had, let's get a lighter color. We had x to the negative 3. You factored out x to the negative 5. So the remaining power, there's the 2 here, x to the, let's see, so the remaining power will be the negative 3 that we had there originally minus negative 5. So that's actually negative 3 plus 5. So that's positive 2. So the exponent here should be 2. And then, let's see, so I have plus, and then for this part of the expression, so it was x to the negative 5. We factored out x to the negative 5, so there's just 1 left over. If we factored out this entire term, then we just put a 1 placeholder there. Now, a nicer way to write this, it's best to take in those expressions with negative exponents, so like this x to the negative 5, and move it to the denominator and write it as x to the positive 5. So this is 2x squared plus 1 all over x to the fifth. That's what this simplifies to. Okay, I'm going to squeeze in maybe 1 or 2 more examples on this page or in this video. Let's see. So what if, let's take something even more complicated. Let's say we have fractions in the exponent. So say you have 5z to the negative 1/6 plus 3z to the positive 1/6. And we want to factor that. So start by factoring out the lower exponent. So you have to ask yourself, all right, what's the lower power out of negative 6 and negative 1/6 and positive 1/6? So the lower exponent will be negative 1/6. Now we figure out the remaining factor. Remember that you subtract the exponent to find the remaining factor. So I have 5, and then here we had z to the negative 1/6. That's exactly what we factored out. So there's no power of z left over. So it's just 5 from that first term. Okay, and then I have plus 3. Oops. Now we had z to the positive 1/6 here. I factored out z to the negative 1/6, so the power that's left over here will be the original exponent 1/6 minus the negative 1/6 power that was factored out. So that actually becomes a plus, right? 1/6 plus 1/6. So that's 2/6. Oops. Which reduces to 1/3. So this is the 1/3 power. And I know these are all getting a little bit messy, so I'll write my final answer maybe a little more clearly here. So this is 5 plus 3z to the 1/3 in the numerator. This term with the negative exponent should be moved to the denominator. So this is z to the positive 1/6 on the bottom. And that would be your final answer. Okay, building up to just one more problem here, and I'm going to clear the screen. So this last example is similar to your chapter R homework. Problem, let's see, I described it over here. I'll do one that's similar to problem number 18 in your chapter R homework. So this is in my math lab. So what you're given is x plus 4. Well, and this is just my version. Remember, these problems are algorithmically generated, so your values might be slightly different. So x plus 4 to the 3/2 plus x times 3/2 times x plus 4 to the positive 1/2. And this is with x greater than negative 4. And I'll talk about why they put this on here in just a minute. Okay, but so in simplifying this, let's take the same old rule of thumb. So there's this common factor of x plus 4. We've got it here and here. So we know we can factor out a power of x plus 4. You always factor out the lower exponent. So when you compare these exponents, 3/2 and 1/2, 1/2 is the lower exponent. Okay, and there are no other common factors. So that's what I'll factor out. Now what's left, so first in this first part, I notice that I have x plus 4 to the 3/2. That's a different power. So I'm going to have some power of x plus 4 left over. To determine the exponent that goes on this, I take the original exponent, which is 3/2, and subtract the power that was factored out, which is 1/2. So that leaves me with 2/2, which is 1. It's to the first power. And if the exponent's 1, you don't really need to write the exponent, but just to emphasize what we're doing here, I'm going to write that. Now we've got plus, okay, x times 3/2. So I'm going to go ahead and multiply straight across. So that's 3 times x over 1 times 2. So I'll just write that as 2. And then here, x plus 4 to the 1/2, that's exactly what was factored out. So there is no power of x plus 4 left over from that term. So that's it for this expression. So we've got x plus 4 factored out. Now what we need to do is combine the terms that are inside the brackets here. So that's an added step in this problem. So I've got that same old x plus 4 to the 1/2 outside. Now, adding the expressions that are inside, notice that this one's over 2. So if I want to combine these terms, x plus 4 plus 3x over 2, I need a common denominator. So I'm going to take the x and multiply numerator and denominator by 2. So I'm going to write that as 2x over 2. Okay, so same thing with the 4. If you multiply numerator and denominator times 2 here, then this is 8 over 2. And then plus that 3x over 2. Sorry. Okay. There we go. Okay, and so now inside the brackets here, that's all over 2. So we can write it as a single fraction with 2 in the denominator. Now combining the terms in the numerator, you've got 2x plus 8 plus 3x. So you can combine the 2x and the 3x, and that's 5x plus 8. And then times that x plus 4 to the 1/2, which can be written as the square root of x plus 4. The 1/2 power is equivalent to the square root. You can write it either way, and it's the same thing. And so this would be your final answer. Now, real quick, I said that I would get back to this x is greater than -4. So the reason for that is because you have this 1/2 power. So this, like I just said, can be written as the square root. Sorry, my stylus is running out of battery, so it's making it a little hard to write clearly. But this x plus 4 to the 1/2 is the same as square root of x plus 4. And so for that to be a real number, x has to be greater than -4. So this is not something you have to worry about when you're solving the problem, but that's why they put that there, is because since it represents a square root, they want you to have a positive number under the square root.